Richard has somebody called Wendy. I have somebody called Paul. Now, Paul came round in the ABC in Sydney to fix the lights. And, I was working away, editing, and he said, hi, very friendly, very warm. I'm a creationist. And so I nodded and tried to get on with my work. And he shuffled again as if to say I'm still a creationist. And I had the same kind of... I get cross. Richard doesn't. He's a very, very even person. But I adopted the kind of attitude when someone comes in and says, I'm a paedophilic pederast and I'm just a human being as well. And I gritted my teeth and smiled again. Anyway, he wanted to talk about this stuff, and so he made the line that he accepted some aspects of evolution, and it goes on in little boxes, in kind of layers. But at no point do these layers get more information. In other words, the little animal stays a little animal and makes other little animals, rather like those bacteria you've got in test tubes. They stay bacteria. They don't become anything else. And so we had a friendly exchange. And as the years have passed, he comes back again and says exactly the same thing. Now, there's several pages of Wendy in the book, and with Richard saying, yes, there are fossils of human beings. You call them missing links, but there they are. They're not missing anymore. And on it goes. Now, I don't want to ask you particularly about your experience with those guys, because you've done that so often. But I do want to ask you about Paul's point about information, that the stuff stays at its original complexity, as if God had made a set of animals which went sideways and changed slightly, rather like those foxes in a doggy way, but no other. What do they have wrong about the term information?
Well, first of all, there are two things here. One is the view that they accept evolution within small limits, as you say, but that they make a distinction between microevolution and macroevolution. And macroevolution is just what you get when you let microevolution go on for a very long time. That's the answer at that level. But the answer at the level of information is that the information content in the genome is increasing in various ways. One way is that when mutation occurs, random change occurs, and then selection narrows it down, that in itself is an increase in information. But the answer that they really need to be told is that the total size of the genome can increase, and does increase, because you get gene duplication. This doesn't happen so often, but every now and again you get a duplication of a gene, sometimes in tandem, sometimes it's duplicated to a completely different place. So you get two different versions of the gene, which are then free to evolve in different ways. So the genome as a whole, the genome of the species, the genotype of the species, can increase in size because of gene duplication and then divergence. And you can do beautiful family tree studies of genes. Never mind about family tree studies of animals. You can do that too, of course, and that's what we conventionally do. You can do family tree studies of genes, hemoglobin A and hemoglobin B, both of which we have. Once upon a time were descended from just plain hemoglobin. And then the genes split, and hemoglobin A evolved one way and hemoglobin B evolved another way. They're still recognizably cousins, but there are other genes which are barely recognizably cousins at all. They split longer ago than that. And so that's one way in which the information content of the genome can increase.
What about before DNA? You believe, well, you seem to give a nod to the RNA story, but RNA is still a pretty complex molecule, like hemoglobin.
There is a problem with the origin of life. The origin of life must have been the origin of the first gene in the more broad sense of the first self-replicating information. Because once you've got that, then natural selection can get going. But DNA is very complicated and not so much complicated, it's very dependent for its working upon the protein world that it is necessary to create. And so we have what's called the catch-22 of the origin of life. Now, RNA is rather like DNA, as you know, in that it uses the same four-letter sequences, slightly different, but in principle they're the same. And if you look at the DNA protein system, RNA does a reasonably good job of doing both what DNA and protein does. So if we go back to the catch-22, you have to have DNA in order to get protein, but you have to have protein in order to get DNA. That's the problem. Now, what protein is very good at is the essential function of being an enzyme, being a catalyst. What DNA is very good at is self-replication in a highly accurate manner and programming the sequence of protein. RNA it's not as good a catalyst, it's not as good as being an enzyme as protein is, but it can do it. And RNA is not as good as being a self-replicator as DNA, but it can do it. And so the RNA world hypothesis is that before you got the DNA protein system, in advance of the catch-22 problem, you had RNA which did both jobs. Well, that's a promising start to a theory of the origin of life. It's not the only one, there are other theories. But the RNA world theory is one theory that's got quite a vogue at the moment, and it's because it has this dual-purpose character.
And before RNA? Clay?
Well, that's another of the theories, that before you got anything organic at all, the theory of Graham, Cairn, Smith is that the very first self-replicating molecules were inorganic. They weren't even organic, they were inorganic clays. That theory hasn't gone down very well in the scientific community. But I think what Cairn Smith gets absolutely right is the need for self-replication as the vital ingredient. And his point that DNA is what he calls a high-tech replicator, and therefore is unlikely to have been the first thing. Something else must have come before it, and then what happened was what he calls a genetic takeover. There was a takeover by DNA of some earlier system.
Well, of course, proteins can reproduce themselves, as we know, to our cost, with the prions.
Well, that's a very special case. Proteins are not at all good at reproducing themselves, and the reason is that the vital information in a protein, it is contained in the sequence of amino acids, just as DNA contains information in the sequence of nucleotides. The protein does have the information in the sequence which is drawn from 20 amino acids, but proteins that work as enzymes are all coiled up. It's sort of knotted up together. And so the sequence of amino acids is not available to be copied because it's buried deep inside the knot. And that's why DNA is so vital, because DNA, it contains a sequence that's not buried. The DNA sequence is available to be read, to be transcribed, to be copied. And from that reading is built up the sequence of amino acids in the protein. Then the protein coils up under the laws of chemistry. And once it's coiled up, the sequence cannot be read out, because it's like trying to read if you take a strip of ribbon and write letters on it and then tie it in an elaborate knot. You can't read the letters anymore.
In about 7 minutes, I'll ask you to ask questions. There will be a couple of microphones downstairs, and then a bit later there'll be a couple of microphones upstairs. I just want to ask you a couple of names. Carl Sagan appears in the book, some lovely quotations, but his first wife doesn't, Lynn Margulis, who has written lots about the cooperative explanation of some evolution, as if there is a kind of way that organisms can come together to produce a kind of different form. Why no mention of that?
Ah, yes, we all have our cross to bear. Lynn Margulis deserves lasting fame for the endosymbiotic theory of the eukaryotic cell. She didn't think of it first, but it was she who really, really put it on the map and advocated it, argued it, and convinced the world.
This is about having organelles like mitochondria and chloroplasts.
That's right.
Which were beasties on the outside and came in.
So the cells that make us up, the large complicated cells that make up most of the large animals and plants that you ever see, in fact everything except bacteria, are themselves colonies of bacteria. And this is a magnificent idea. It's almost certainly correct, and to her goes the credit for it. That was a vital step in evolution, and from it much followed. But more recently, she's gone overboard for the idea that there's something almost mystical about cooperation. Now, cooperation does, of course, happen, and my own first book, The Selfish Gene, is quite largely about cooperation. But Lynn Margulis has jumped to the view that this is somehow an alternative to Darwinian evolution, and she's set herself up as a sort of anti-Darwinian evolutionist, which is just unhelpful and doesn't illuminate in any way.
Before I go to the audience, I want to ask one last question myself about design. Now, there's in the male there's the prostate. I mean, really. With women, it's having to give birth with all that appalling agony. And then with the giraffe, is it the laryngeal nerve?
The recurrent laryngeal, yes. Yeah.
Which goes round the houses and back, as if it's doing a day trip somewhere.
Yes, that's right. The body is filled with these examples of lousy design, which result quite clearly from history. And it's easy to see why they're there. They're historical relics. And the way evolution works is to take what's already there and modify it. It's been called a tinkerer. And if you constantly tinker, if you never are allowed to throw it away and start with a clean sheet on a clean drawing board, which is what an engineer does, if you had to evolve the jet engine instead of designing it by taking a propeller engine and change the propeller engine one screw at a time, one rivet at a time, think what a clumsy apology for a jet engine you'd end up with. And that's the way, I mean, in a way it's remarkable that living bodies are as good as they are, considering that they are tinkered about from history. I mean, what happens is that there's a sort of botched job, and then natural selection comes up and kind of cleans up around the edges and ends up with not a bad approximation to a good job, but nothing like as good as you'd get if you started with a fresh drawing board.
I've told you before, there's only one great example of undoubted intelligent design by God, and that is the creation of homosexuals. Because obviously there's no compelling evolutionary reason that God would have done it except to give us K.D. Lang, George Michael, Leonardo da Vinci, half of my department in the ABC. I mean, it's fantastic. Where would we have got? Anyway, yes, please.
We've all heard the story about the tall giraffe eats the leaves and survives, and now everyone knows that story. I don't believe it. Firstly, male giraffes are 2 to 3 feet higher than female giraffes, so the tallest would be starving to death the females which reproduce. Second point is that the baby giraffes, or giraffes when they're first born, are only 6 feet tall. And they are weaned at 8 to 10 months, and they take another 5 to 7 years to reach maturity. So surely, once weaned, they're on their own and wouldn't survive. They'd be starved to, the species would be starved to extinction because the younger generation...
Your question?
I'll take it from there.
Fine.
Okay. This is a familiar type of question. What you say might be right if there was a kind of if it was like a sort of hedge where the trees were upside down hedge, where there was a sort of level below which there weren't any leaves. And then you'd be perfectly right that males could reach it and females couldn't, or juveniles couldn't and adults could. But it's not like that, is it? Because what nature provides us with is a whole range of trees of all different sizes and shapes and heights. And so there will always be some height of tree which if you were just a little bit taller you could reach, and if you're a little bit shorter you couldn't. And so there's a continuum of trees, a continuum of heights of leaves that it might be worth reaching, so that however tall you may already be, whether you're male or female, adult or juvenile, there still could be some circumstances in which you're better off being a bit taller. Now, I'm not necessarily in any case buying the view that reaching the tops of trees is the reason why giraffes have such long necks. It could very well be. There could be other reasons. But whenever you come across an argument like that, and it's very familiar, you come across it with things like how could wings develop? There's always going to be some tree which just makes the difference between getting a leaf and not getting a leaf.
No, we have to go quickly because there are lots of questions, if you don't mind. Yes, please.
It's in the interest of a Western democracy that the head of state of, such as the current Prime Minister of Australia, openly holds irrational, unsubstantiated beliefs. And in your opinion, is such a person of superstitious and religious disposition mentally competent or rational enough to hold a position of such a high public responsibility?
This is going towards the Atheist Conference next week, isn't it? But you open the book by talking about the Bishop of Oxford, with whom you have had very constructive relationships.
Yes. I don't know what the actual views of the Prime Minister are. There's, of course, a great range of views that come under the general heading of religion, and Robyn's mentioned the bishop of the previous Bishop of Oxford, Richard Harris, who is pretty much not very different from us. I mean, he just sort of has a few religious beliefs left. And on the other hand, you've got Sarah Palin, whose beliefs are just plain bonkers. And I don't know where does the Prime Minister of Australia fit along that continuum?
I'm not sure, but I would just refer you to the book because that's what we're here to talk about. And if you look at page 212, you'll see several verses of which I'll read only two. All things dull and ugly, all creatures short and squat, all things rude and nasty, the Lord God made the lot. Each little snake that poisons, each little wasp that stings, he made their brutish venom, he made their horrid wings. All things sick and cancerous, all evil, great and small, all things foul and dangerous, the Lord God made them all. Is that actually a song that the Monty Python people sing?
Yes. It's the Monty Python version of All Things Bright and Beautiful, and it's sung on one of their films by a group of cherubic choir boys. It's really very, very nicely done. I think it's a little bit unfair, but I think I haven't really answered the question.
Yes, you have.
I would very much like to see heads of state who hold rational views, and so I was not a supporter of George Bush, and I was not a supporter of Tony Blair. But I think it would be rather hard I certainly wouldn't wish to legislate against heads of state having religious beliefs.
Well, you couldn't run for office in the United States if you said you were agnostic or an atheist.
You couldn't. No, you couldn't.
No hope.
But getting back to All Things Dull and Ugly, it's a lovely song, and it makes the point that God didn't only make things bright and beautiful; He must have made the venomous eastern groin gropers and things like that. Is that a real... Yeah, we've got a big audience here. I'm fascinated by this. Bill Bryson, in his book on Australia, which I'm now reading, talks about a poisonous snake called the eastern groin groper.
That's a bloke.
He's having us on. He's having us on, isn't he? What? Can anybody here vouch for the eastern groin groper?
Have we got another question over that side? Yeah. Yes, please.
Yes, we do. Neil Byrne. What I wanted to ask, in campaigning for rational thinking, in your campaigning for evolutionary science, there's a perception perhaps that you expect someone who appreciates evolutionary science to reject religion. And yet there are lots of great evolutionary scientists who are also deeply religious. Am I misrepresenting your position? Do we have to take out organised religion in order to be good scientists?
No, you're right. There are some excellent evolutionary scientists who are also religious. An outstanding example would be Kenneth Miller of Brown University in America. They vary. There are some of them who are sort of evolutionists but think that God helped evolution over the difficult jumps. There are some who are evolutionists but think that God started the whole process off. There are some who think that God started the universe off. And so there's a whole range. I think I would be worried about anybody who actually resorted to supernatural explanations whenever things got difficult in trying to explain something by natural explanations, and the best ones don't do that. I also think that there is a kind of antipathy between the message that you get from studying evolution, which is that we explain complexity from simplicity. We take original simplicity and we actually have a very good explanation for how you can get from that to complexity and mind and creativity and intelligence and all the things that you would need to have if you were going to be a god. And so if you postulate a god as something that was there in advance of evolution, then in a way you have denied the whole enterprise, because you've admitted that you're prepared to postulate something which is the very kind of thing you're trying to explain by your evolutionary ideas. So I think it's a sort of cowardly cop-out.
Natural selection, I guess by definition, is natural. With human sort of manipulation of what is natural and seen with things like global warming and things like that, I'm interested to get your opinion on how you think humans might have manipulated the ability of natural selection to progress into the future.
Well, we've been manipulating selection for quite a while in the form of artificial selection. We've been doing that for hundreds of years, thousands of years. We talked about that with respect to dogs earlier. As for the future, we are moving on from just manipulating the selection part of the equation to manipulating the mutation part of the equation. Hitherto, mutation has been random in the sense that it's not directed towards any particular end point. And so when you want to select dogs for tameness or cabbages for nutritiousness, whatever it is, you exploit the natural variation, which is random, just wait for it to come around, get redistributed by sexual reproduction, and then choose. Nowadays, with modern genetics, you can actually manipulate the mutation part of the equation as well, actually deliberately cause genes to mutate or implant genes, pick up genes from one, maybe from a plant, and put it into an animal, or vice versa. And this will presumably increasingly be possible to do. And so I would think that scientists of the future might look back on the 20th and 21st centuries as being a kind of glitch in the evolutionary process, which is when mutation stopped being random and started being directed by intelligence, when indeed intelligent design really did begin.
What about that thing that I sometimes have vigorous words with Peter Singer about? You know Peter Singer, now at Princeton, where we talk about genes for Harvard and genes for a gold medal at the Vancouver Olympics. And it's always been my opinion that it's so difficult to do that it seems to me within the next several hundred years to be pretty well out of the question.
It's politically frowned upon to think about selecting for or engineering ability to get gold medals in the Olympics. But you don't need to even do genetic engineering, because you already know that you can breed greyhounds for speed, you can breed horses for speed, you can breed cows for milk yield. If you wanted to breed champion high jumpers in a few hundred years' time, I have no doubt that you could do it. I mean,
the usual way.
Yeah, you wouldn't need to manipulate genes. You could probably do it even faster if you manipulated genes. But if you simply crossbred male champion high jumpers with female champion high jumpers for a few generations, you probably do it.
Not a bad idea.
Hi, Professor Dawkins. I was just wondering, in some of the early chapters of your book, in addition to artificial selection, you talk about hybridization. And one of the examples you use is the Labradoodle, where a dog is created by mixing two breeds together to get the best characteristics of both of them. Now, at what stage does a hybrid become, let's say, a pedigree or a breed of its own? Because if you take the Labrador, the Golden Retriever, they in their own rights are, just about 100 years old, and the Labradoodle is, about 21 years old? And also, what star sign are you?
I think that what happens when you're doing something like breeding dogs, or indeed, this sort of hybridization is done very much now in agriculture. You very often find that the chickens that are used for meat, or the cows that are used for beef or whatever it is, are themselves hybrids, and so you keep a stock of two purebred kinds of animal, and you constantly cross them to make crossbreeds for the ones you actually use. Now, I think there are, in the case of Labradoodles, there may be experts on breeding dogs here who'll correct me, but I think that there are two things that can happen. One is that you go on crossing Labradors and Poodles in order to get Labradoodles, and that's one way of doing it. But there may come a time when if you cross a Labradoodle with a Labradoodle, then you get another Labradoodle. And that won't happen at first. You're much more likely to get a whole range of intermediates. Some of them will look just like Labradors, some will look just like Poodles, and there'll be all sorts of strange things going on. And I suppose the answer to your question is at the moment when it becomes possible to reliably get a hybrid to breed true, when you cross it with another hybrid and get one that looks the same, then you've created a new breed. And many breeds of dogs and other animals have been produced in just that way.